All right, so that leaves us with this star math example, which is the most complex of the activities. So what is it I'm wanting to do with it? I mean, just in terms of what you see on screen, you see a bunch of stars or some other shape or polygon, whatever you like, and you see numbers inside of them, but they're no longer counting. They're random. So each star has a number value that is randomly generated when it is created. And then the idea of the app is to add these stars as display groups again to a table. And then after they've been created, to scan through the table and do some math. So we're going to run through all these stars and access their values, total them all up, and then create an average and report the average. So in other words, it's another payoff of having your program objects in a table. Is after you create them, you can work with them, and you can also kind of scan through the table to generate some sort of report. Okay, so I'm going to build it up, and stop me if something's not making sense. So we'll start with a polygon, and if you want to use a shape that's different from that triangle, then you can select any of the shapes. So this has the same start kind of as the last one, which is we have a star and we have some text. It's going to get a random number, so I'm just going to start out without a number in it. I would start at 0 if it was a counter, but it doesn't really make sense when I'm going to randomize it. So let me see. I mean, if you're doing it, you can also pick different colors and outlines. And actually, in the version in the keynote, you can see I've shaded the triangles grayscale, and then I've also a little bit tricky. I've recolored the number value to contrast with the shade. So if it's a dark shade, you might notice that the numbers are white, and if it's a light shade in the triangle, the numbers are black, so that you can read them all. I don't know that we'll do that in this example, but it's in the keynote. Okay, so that's a star with a text display object sitting on top of it. I need to put that into a display group, so we'll create a display group. You can call it whatever you want. I think I called it star group. That can be any valid Lua identifier. And then I need to add the polygon. Let me blast this out so that you can maybe see this. I want to add the polygon and the text to the display group. Oh, that's not good. That's funny. So yeah, the plumbers are still here working on the shower, and apparently they've set off the smoke alarm, or it's an actual fire. Stay tuned. I will let you know. That's okay. So the polygon needs to go into the star group. We do that by hitting the Add to Display Group button, selecting the group. Again, we only have the star group. That's what we want, or whatever you called it. Text also goes into the display group. No, I just did that. What did I do? Add to display group. Change display. All right, I clicked the wrong button. There we go. Star group. We now have a display group. We just have one. So if you ran it and tested it, obviously you just get a star with a dash dash inside of it. So we want to create a table of these display groups, randomly position them using a random number generator, and then set their value also to some random number to start out. So we'll use a snippet to do that. So if you head over to the snippets objects, we can use a new snippet. We're gonna do a loop, obviously. So I'll call this create loop, and we'll use a for loop because I didn't say anything about randomizing or basing the number of stars on some weird criteria. I think I just say create. I think I create 10 stars. So we'll do a for loop. We'll say for j equals 1 to 10 do. And I know it's more kind of common in programming to use I instead of J for the index, but when I do I, it capitalizes it, which drives me crazy. So I use J so it doesn't capitalize it. So we want to create the stars now inside of this for loop, and so this is where now we have a choice. How do we want to do this? I think in this case, since we've got three snippets that I want to surround with the display group, I think I'm going to use the multi-snippet approach. So I'm going to use this first snippet, if I can do it, to be the for portion, and I'm going to put it up above the object 1, object 2, and object 3. So I'm just going to move it up, and I'm going to change the description just a little bit to say create for loop begin. So now I've got a partial for loop, the start of a for loop in object 4, 3 things I'm doing inside the body. I need the closing snippet then, which will be, for loop end. Let me zoom in on that too, because we are gonna write some code in here as well. At the end, just so that I don't forget it, we actually need the end, because that's the end for the for loop. So looking at your stack, object 4 starts the loop, object 5 at the bottom ends the loop. Everything inside or in between those 2 snippets then is part of the body of this loop. It will execute 10 times as we've written it. So what else do we want to do? Well, if you look over at the keynote, I described some of the things we do. One of which is we randomize the XY values. And this uses the same technique we did on the last example, because we're using a display group in the center of the screen. We'll use minus 160, plus 160, minus 240, plus 240 to randomize the location. So, I mean, let's do that. I think I called it star group, right? I have not enough screen space now. So we're going to randomize the X and also the Y. We're going to use the exact same syntax we used last time, which is math.random. I'm out of screen space again. And we'll say minus 160, comma, plus, or just 160. And I'm still out of screen space. All right. And then for the vertical, we'll say math.random minus 240, comma, 240. So that will randomize the location of that triangle, or the star and number, and then I want to give it a value. So I'm actually going to store that in the star group itself, and it's just a random number. I think I just did, yeah, between 1 and 10. You can do anything you want, but it's just an example of giving this display object a value. So importantly, this doesn't exist. I mean, there is no value attribute on display groups. So this is where, again, Lua is really cool. If I want an extra attribute to something, I just use it. So I can give this display group a value attribute just by adding that dot value on it and assigning it some number. That creates a new attribute on that display group and assigns a random number to it. So, I mean, thinking about the lab day a little bit, I've asked you to create an image object, the bug, and I've asked you to give it a random XY location, and I asked you to give it a damage attribute. So that is identical to this, except it's not value. I would call it .damage, and you're not going to give it a random number. You're going to start damage out at 0. So for your lab day, it would be something like buggy.damage equals 0. Instead of just saying it, why don't I just type it real quick? So if your display group or your bug display object was called buggy, you'd say buggy.value. No, wrong, buggy.damage equals 0. So that would add the damage attribute, and then you could increase damage by saying buggy.damage equals buggy.damage plus some random damage value using math.random. So really similar to what we're doing, which is why I wanted to get it out early so that I could mention that and make sure you guys were on track. Okay, so just thinking about what we've got. We've got a loop. It's creating 10 display groups called star group. Each star group gets a random XY value, and each star group gets a value attribute, which is a random number between 1 and 10. So we also want to set the text in these stars to the value. So I want to look at the design or at the stack real quick and see what is the text. The text is object 2. So for me, I'm going to say object 2.text equals star group.value. Keeping in mind that if you've done it at all different from me or you're using a different approach, that might not be your object 2. Object 2 is the text display object. Okay, and then the table. I want to put these in a table. I have not done that yet. Before we do that, let's just practice what I preach, which is let's save it. This is, I've called it star math here. So let's save it and let's run it and just see what we have to see if I've gone astray yet. So waiting for the spinning beach ball of death, and still waiting. Still waiting. Wow. I should have started this in the background and then gone on and done something else. Okay, so there's the array of stars with random numbers in them. So I haven't done the gradient background. I haven't shaded the star, but you guys know how to set fill color and do stuff like this, and how to create gradients and how to create a gradient background. So I'm really just more interested in the mechanics of how do we create this table and how do we scan through it to generate report data like a total or an average. So I don't have the table. So that's the next step is I do not have a table. So I need, we can create a new snippet for our variables. So I'll call it setup. Let me zoom in. I hope my fonts or my screen is big enough that you guys can see this, but we want to create a table of these star groups. So you call it whatever you want. I'll call it stars. I want it to be a table, so I give it the open and close curly braces, so it's an empty table. And I'm going to put that up above my for loop because I want to use it inside of the for loop. So I can't have it after the for loop. So I'm going to jump back to the bottom half of the for loop after I do the value. In other words, after I've set up everything about star group, then I want to put it into the stars table. So the syntax is table name, stars, square braces that surround the index number, the counter, which is j in this loop, and it's equal to star group. That's not spelled right, star group. So let me just leave that on screen for a second and see, are there any questions? But I've just, yeah, sorry.
Sorry, why are we putting this in a table now?
Because I want to be able at some future point to access all of these stars and do something with them. So in the previous examples, like in Clover Tap, there was a timer, and every time the timer ran, we re-randomized the X and Y location of the clovers. The only way to do that is to have some name for each clover, some way to access each clover. But they were all just called some sort of display group name, or they were all object one or something. In this case, my star groups are all called star group. Every one of them is called star group. So later, if I added a button and pressed the button to say generate statistics, there would be no way to access all 10 star groups. I just have the one the one handle. So by putting them in a table, I make them addressable later in my code whenever I want to access them. And I did realize this, I didn't put a button in this example. I just, in the example, in the keynote, it generates these random stars, and then there's a pause, and then it calculates the average and stuff. But it probably makes more sense to have a button to make the usefulness maybe of the table a little more clear. So that's what I'm going to do this morning. But
So
yeah, yep.
I'm sorry. You create the table by putting stars, and then like the square braces J equals star, right?
Yeah, so I declare the table up at the top of the code. So I give it some name like stars, and I say it is an empty table. That's the syntax that says,
Okay.
wow, that's loud. Make this an empty table. And then inside of the loop, I fill the table up. So I create, this is going to loop 10 times in this case. Each time it creates a new randomly located and valued star group, and then it puts that star group into this table of stars. So coming out of this loop, I'll have a table called stars, which has 10 members, and they're each a random star group. If I ran it right now, it would not or should not change any aspect of what we saw on screen because I haven't done anything else yet. This is just laying the foundation to take the next step, which is let's add a little button, and then inside the button event handler, let's access this table and calculate some values.
Can you go back to the first snippet?
This one?
The top one, I think.
Let me head over here just so you can see it. Maybe see it all in context a little better.
Thank you.
So we set up the table, then we start the for loop. Inside the for loop, these are just the object 1, object 2, object 3 script objects, unchanged. And then down here is the bottom part. No, sorry, down here is the bottom part of the, oh, why is that not indented? That's annoying. Okay, the bottom part of the for loop with the extra stuff we did to randomize x and y, to set the value, to put it in the table. Yeah, I don't want to rush over this, so any other questions? Or the basic idea, though, is I've got this object 1, object 2, object 3 that create this star display group with a number in it, and I want to create 10 of them. So I put them in a for loop to create 10 of them. And then I want to configure their XY value, give them a random number, and store them in a table. I also do all of that inside of the for loop, so it's done 10 times. And so if you don't like for loops, I mean, the other way to do this would be to create a timer that fired 10 times and put all of these snippets into the timer event handler. And in fact, in drawing a code, that's probably easier because obviously I support timers really well and not for loops. So if that approach made more sense, that's absolutely a good way to do it. And I think that's the way I do it. If you download the star math example in the chapter resources, I think that's the way I do it. All right, moving ahead. Let's add a button. You guys know how to do that. So your favorite button. Keeping in mind that if you add an image button, which is everybody's favorite, then you'll have to come up with the images. So I'm just going to add a text button and put it somewhere, and I'm going to call it or name it or text it statistics. Statistics. There we go. So that is, if you look at your stack now, if you've done something like that, you should see a button, script object, the on-press handler, and then a snippet with the default button support. So that's what we want to edit is the, sorry, where's my, this snippet, which for me is object 9. It might be a different, again, it might be different for you, but I'm looking inside the button press handler for that default snippet, whatever that number is. I'm going to head back over here and kick it out to a big window, zoom in so we can all see it. Okay, so the idea now is I want to be able to report on the average value of all these stars. So again, this is where I don't have access to star group. Star group is inside of that for loop. And even if I could access star group, there would be a way to do that, but I would only be able to access the last star group that was made. I wouldn't have access to all 10 of them because they wouldn't have been stored unless I stored them in a table. So the point of the table is to store your work to make it accessible later. So how do we do that? Well, you use a for loop again. So we'll say something like for j equals 1 to 10, or you could say 1 to pound stars if you wanted to have the opportunity later to change the number of stars. That way you wouldn't have to recode this line. So let me skip forward on the keynote. There we go. The idea in the keynote is we want to report on the average. So I mean, obviously you guys know how to create an average. You've got to total something up and then divide by the number of items that were counted up. And in this case, we know the number of items is 10 or pound stars. We don't know the total of all those random values though. So I need a variable to total it up. So I'll say total equals 0. And then inside this loop, I want to add all of the values up. So the syntax will be total equals total plus, we add a space in there. Total equals total plus. Well, so that's the easy part. So how do I access the value of each star one by one? I need to use the name of the table, which is stars. I need my square bracket. I need an index number. I've used J again. You don't have to. You could use any index here. And then to access the value, it's just dot value. Each star display group has a value attribute called value, and I can access it by just using this table dot attribute syntax, which we've gotten used to using, I think, over the last several weeks. That's yeah, I do some other stuff in the keynote. I use a couple of transitions to fade the. I fade the each of the stars out slowly, and then I fade in the report, the little report box which says average equals 5.42. I can do as much of that as you guys want to, but what's new here is kind of the calculation. So I want to then calculate average. So we could say average equals total divided by 10 or pound stars, or however you want to. Let's 10 for simplicity. And let's display it just so that we can see, if it's working. All right, so here's our example. There's our button. So the button's off because I'm using a taller screen, so we could move it down just because that bugs me. If we hit statistics, what we should see is at your console this number, and if we restart the, did it do it? Oh, if we wait for it to reload, there we go, and hit statistics again, you should see something I mean, close to 5 would be the average if we go from 1 to 10. So that's pretty close. All right, anybody trying to follow along and stuck or questions at this point? I don't want to rush over it. I haven't done everything that's in the keynote. Again, I haven't done the shading and the coloring of the number. I haven't done the gradient background. I haven't done any transitions. We can do any or all of that if you want to see it, this morning. But the really important part is to get this number. That's the math. That's the beauty of storing data in a table, and then being able to run through it and do work with it. In the other examples previous to this in the chapter, we've moved stuff around on screen, which is fun, absolutely fun. This is a calculation example though. So yeah, again, unfortunately I realized halfway into this I did it differently than I did in the chapter and in the keynote example. In the chapter and the keynote example, I used a timer to create the 10. In this example, I used a loop, which then gives us 2 loops. There's a loop when the app starts to create 10 stars, and then there's a loop every time the button's pressed to calculate the average. I haven't done a good job here. That snippet still says it's the default snippet, but this is actually the average calculation. If you'll make those little changes, it makes your stack just easier to read and understand, either for somebody else or even for you. Other questions, issues? Do you guys want to see any of these transitions or the shading of the star? And I guess the only trick would be, it's tough to use drawn to code to write the transition for you, because there's no way to tell it to look at, say, stars. I mean, stars J would be what would want to transition, and I can't select that when I write when I use drawn to code to create the transition. So for these examples, in this activity, I just type it in. I mean, I've gotten used to. I mean, let's do it really quickly. The syntax for transitions is super easy. It's transition.to. So transition's a table, to is a function, and then you tell it what do you want to transition. In this case, it's stars J. And then there's a table of transition settings, which you just think through. What is it I want to do? So the transitions require an amount of time for the transition. Defaults to 1 second. And then something that you're changing. An X value, a Y value, a scale value. In this case, we could just fade them out. That's what I did in the keynote. And we can also delay, which is probably not a bad idea. I want to leave those stars on screen for a second. So I'll say delay 1000. There we go. And I'm going to say time equals 1000 and alpha equals 0. So all that is saying is, when you loop through and create all these stars, or actually after you push statistics and calculate the statistics as you're doing that, we're going to take each star and transition it out to leave the screen empty for us to present the average result. So these are milliseconds. If you wanted to add more variation, you could make that a random delay, so the stars kind of twinkle out or whatever kind of seems like it might be cool. So this should leave me with a blank screen, but with the average down here at the bottom. So then in the chapter example, the keynote example, then I fade in this little box that says average 5.42 in the keynote, which is, I mean, it's not fancy. It's just a white rectangle with a text display object on top of it. There's nothing fancy about doing that at all. And I fade it in. So, I mean, we can do it really quick. I don't want you to miss anything. So it's just a rectangle, and it has some text on it. The text obviously can't be white, or the rectangle can't be white, and I'll just leave it as nothing for a moment, and then I put it in a display group. So let's call it result group, and then I'm going to add that rectangle to the result group, and the number, or the text display object, to the result group. And I'm going to make it alpha 0. No, not this one. So sorry, I'm doing the wrong one. I want to go back to the, where's my stack? I want to go back to the display group. I want to make the display group alpha 0 and not visible. If I make it not visible down at the bottom, then I can hide stuff that's not visible here, which makes anything that I've made not visible disappear from the design, so you can keep working on stuff that is visible. And so then I want to add another transition. So if I want to transition the stars out so they disappear, then I want to transition in the result group. But of course I want to add the average to it as well. So this is all in this snippet, which has the transition out inside the loop. I don't want to transition result group inside the loop because I want to calculate the average first. I want to update the text in the result group, which is, doesn't say, object 12. So I want to say object 12.text equals average. And this could obviously end up being too many decimal places. Certainly for lots of reports, you run the risk here that this will have like 20 decimal places or something. So if that's a risk, then we'll add the rounding function to our stack and then round it to a certain number of decimal places. That shouldn't be an issue here, but in lots of this kind of work, for instance, when I was coding the bug defense app last night, you can't end up with lots more decimal places than you want. So I used the round function to round it to 1 decimal place. Anyway, we want to fade back in the result group because the stars are faded out. So there's a couple things. First off, we've made it invisible 2 ways. We zeroed out the alpha, and we also set it to be not visible to Corona. So I want to set it back to visible, which the syntax will be result group dot is visible equals true. If you wanted to use a set attribute, you could do that as well, but I think it's even easier just to type it, of course, unless I mistyped it. And then I want a transition. So I've made it is visible, but remember the alpha is still 0. So I've just set it up now, so now I can fade it in dramatically. So we'll say transition 2. It's a function, so I have my parentheses. The target is result group. And then I need a table of settings, so I type in my curly braces, and then I'm ready with some key value pairs to fade it in. So at a minimum, it needs a time. So 1,000. And then we need what is it we're changing? So we're changing the alpha to 1. You could add a delay or other stuff if you wanted, but that's kind of a bare bones fade in effect. Let's see what it looks like. Let's see what it looks like. There we go. I hope that's it. Well, yeah, so I delayed the fading out of the stars a second, so they overlapped briefly, but that was kind of cool. I didn't mind that. Any questions? Anybody trying to follow along to get something like this to work and it's not working? I mean, that's most of the complexity in that last example, chapter 9. So you guys are, I mean, at this point, I think you should be really comfortable with dragging stuff around, using the touch listener, um, detecting collisions between something that you're dragging and something else on screen using overlap detection, writing that overlap detection into the touch handler. Um, that's still not real collision. I mean, I call it collision because it kind of feels like you're dragging something into another object and you're colliding with it, sort of what it feels like. But um, you're really just detecting overlap. The real collisions happen when you turn on the physics engine and physics bodies start hitting each other, and that's what we'll do next. I'm hoping also you're pretty comfortable with timers, starting timers, placing code in the right part of the timer of a handler to get it to do stuff that you want it to do. Um, and then we've got several more examples in this chapter 9 of using Lua tables to do stuff for us, storing stuff in tables to make it accessible later when we want to have access to data that wouldn't have been stored if we hadn't have stored it in a table for whatever we want to do with it. All right, awesome. All right, so you should have gotten a link through Skype to the live keynote for chapter 12, and it is still starting, so there may be a couple second delay as it gets itself situated properly on Apple's servers. It's just a lab. Yeah, I mean, you should obviously continue reading and doing homework. We'll do the homework check. We'll do the homework check next time. I added a bunch of detail on where is it, on the homework check to the course app, but that's a great question. So I was thinking for the homework checks, Skype seems to be working okay, and maybe I just have you guys essentially call in and share your screen with me, and I could ask you to watch, some of your apps and stuff, kind of like we were just sitting in my office. But I realized that would keep me really busy, but you guys would probably spend most of your time waiting um, to share your screen. I think it would be a huge waste of time, and time's kind of valuable, obviously, for everybody. So I think what I'm going to do instead is on Tuesday we'll cover some more physics, and then after we're done covering some physics, I'll just I'll just do an app, kind of like we've been doing, that uses sliders and functions and the stuff that we've been learning about, and you'll follow along, add a couple features, and then you'll just email me the result that you got working, um, that shows how that you could do all the stuff in the homework. So that's the plan right now. For homework check 3, if that goes well, we'll do it on homework check 4. If it goes poorly, I'll rethink it.
Great.
Anyway, the description's all here in the course app. All right. All right, awesome. I guess it would make sense just really briefly to look at bug defense. Okay, so yeah, bug defense. I mean, I gave you a gameplay movie, so you kind of get a sense of what it does. But all it is a table of 50 bugs. They're the little buggy graphics. There's a button. I went ahead and used an image button to make it cool. And there's a little text display object with some summary statistics, which are optional if your team is feeling ambitious. And then when you hit the button, this spell wave passes over all the bugs. All that is a rectangle that has a gradient applied to it that goes from white to nothing, and I transition it up the screen. So if you watch knowing what it is now, you're just watching a rectangle slide up the screen. After it's done, I reset it back below the screen for the next time you hit the wave. As bugs are damaged, I'm just adding a random amount of damage to each of their damage value attributes. When it hits 100, I start transitioning them off screen. And then if you're ambitious, you can count the spells. You can count the bugs that remain after the last spell, and you can calculate the average damage for those bugs to kind of give you an idea of how healthy they are. And interestingly, in most cases, it's like 6 spells and they're all gone. But in the one I videoed for you guys, if you watched it, there's this last bug which is tremendously healthy, and he sticks around for, I don't know how many. It's like 10 waves before we finally get rid of him. But that's random numbers for you. If you're ambitious, there's more stuff you can do. You can animate the spell, you can do the statistics, you can do a magical sound as the spell goes over the bugs, and you can do a spell when the bug finally disappears, or whatever you want if you're having fun for bonus galleons. Well, if something pops up, let me know. But let's take a peek at physics and get something going to give you something to look forward to. And I know a lot of this. Well, I don't know. A lot of this is fun to me. Certainly, the last chapter was fun, but stuff really starts to get fun when we start learning physics. My only caution would be, I keep saying it's fun, and it is fun, and I enjoy it, and most of the students enjoy it. But fun doesn't necessarily mean every aspect of it is super easy. Um, it is not terribly difficult. I'm not intending to scare you, but don't confuse the fact that it's a lot of fun with it's all just going to make perfect intuitive sense, and you won't have to think hard to do it at all. Okay, with that said, to start physics, we've got an entire physics object palette. It's called physics. We've got a bunch of buttons enabled, a couple that aren't enabled yet, although I've been working on adjoint. So if we know we're going to be using physics, we'll start off by essentially creating a script object that lets us work with physics. So it's called setup physics, and the control panel here allows you to start and stop physics, change the draw mode, which we'll talk in depth about later, and also gives you control over gravity. So that's pretty cool. Default gravity is 9.8 meters per second squared, and X gravity is 0, but you can, again, you can play around with gravity to your heart's content. None of this does anything, though. It just sets us up for then adding stuff on screen, which the physics engine will apply your physics settings to. Okay, so I think I did this maybe on the first day of class, but let's start off with the simple ball example. So I've created a circle. We're going to call it a ball just because we're going to make it act like a ball. By itself, though, the circle is just a circle. If we want it to work with the physics engines, or we want to pass it to the physics engine to work with, we have to add it as a physics body. So going back to the physics button list here, the add body button is what you want. If you've selected what body you want to add in the design or in the stack, that'll default to the selection here. If you, for whatever reason, if you didn't select it, you can pick something else from the combo box. Let's look at the stack. So not a lot in the stack. Setup physics, a circle, and the add body script object. Let's run it. All right, so I don't know if you caught that or not. You can hit Command R, Control, or Command R, or Control R to rerun it. And you should see the ball appear and then just drop. So, I mean, what's happening is it's added to the physics engine, gravity takes hold, and you see it accelerating down under the force of gravity, which isn't super fun, right? We'd really rather have the ball bounced, had something to bounce against. So how do we do that? So it does confuse some people because there's kind of almost this expectation that the edges of the screen are somehow physics boundaries, like the ball should bounce off of the bottom of the screen. They aren't. You could add objects to make them boundaries, but you would have to do that. So if we want a ground for the ball to bounce against, we're going to need to add it ourselves. And it's not a widget. It is let's say a rectangle. And you put it down about where the ground would be. And you can color it with something that's more ground-like, brown or green grass or whatever you want. If we save it and run it here, I forgot to save the design, so let me do that too. We'll say it. We'll call. Oh, yeah, we didn't see it. Ball drop. Okay, so if you're watching, you would have seen the ball drop. You see the ground at the bottom, and you would have seen the ball just pass directly through the ground. Why is it doing that? It's because the ground there is just a rectangle. We didn't add it as a physics body. If we want it to be part of the physics engine, we have to add it as a physics body. So select it, head over to physics, add body, add the rectangle. For me, that's object 4 if you're trying to follow along. Save it and watch it this time. And you might remember what happens, or if you've read ahead, you know what's going to happen, but it's maybe not what you expect. You'll see the ball, you'll see the ground, and you'll see the gravity acting, and everything just falls off the screen, right? Because although we're calling that rectangle ground, that doesn't make it ground. It's just a rectangle. Under the force of gravity, it's going to get pulled down just like any other display object would. So we need to say, no, we want the ground to stay put. Quick to change, but we want to go to the add body statement for the rectangle. So this button here just allows you to cycle through the different type of physics bodies. There's dynamic, which is the default, which means it gets pulled down or affected by the force of gravity. Static, which means it's in the physics engine, but gravity does not affect it. And then kinematic, which means you can move it around. It does stuff kind of as a hybrid between static and dynamic. So sorry, the ground we want it to be static. Static says stay put, but it's in the physics engine, so stuff will hit it, and it will act as if it was an actual mass in the physics engine. It should bounce off of it at some point. There we go. All right, so if you're following along, it's not super fun because there's not a lot of bounce. For whatever reason, the default bounce is kind of low, but you have control over it. This is your world. You control the physics in this world. So if you go back to the settings for, say, the ball, the circle, look at its physics setting, which is in the add body statement. And you can see up at the top, we have control over bounce, friction, density, shape, type of physics body, and various other settings that give us control over the physics world. So to make the ball bouncier, you probably could figure this out without me telling you. You're going to grab the bounce slider and move it to the right. 0 means not bouncy at all, like a bag of sand. And then a bounce of 1 means perfectly bouncy. So 1 returns all of the energy from the collision back to the ball, so it will bounce forever. So I made it 0.9, which is decently high. We should get something that bounces a little more lively here. Spinning beach ball, there we go. So yeah, that's a bouncier ball. And you have control, again, if you move the ball up, you get more, more energy in the first collision, and it'll bounce longer. So again, just looking at while that's loading at the keynote, dynamic is reacts to gravity and collisions. Static is it doesn't move or react to gravity or collisions. It does report on collisions, so you know when it's hitting the ground, but the ground isn't moved by the collision with the ball. Kinematic is halfway in between. It's not affected by gravity, but it is affected by other forces like collisions. So if we made the ground kinematic, when the ball hit it, the ground would be shoved in the opposite direction away from the bouncing ball, as per Newton. Questions? All right, so the keynote just shows you, the next slide is adjusting the bounce. If you can go past 1. You might be thinking, hey, 0.9 or 0.91 is pretty bouncy, but what if I max it out to 1? And then if you did that, you might realize I can go past I can go past 1. So again, this is you're in command of the physics of this world. If you want gravity to or bounciness to work in amazing ways so that it it returns more energy than it imparted when it hit the ground, you just do it. So 1.25 will cause each bounce to be higher and higher and higher and higher. All right. So one of the things, while that's bouncing, one of the things that can be a little confusing is just, let's look at the stack for a second. We've got setup physics, which gives us control over gravity and such things. We've got two shapes, object 2 and object 4, a circle and a rectangle. They are just a circle and a rectangle display object. And then I've got two physics script objects, object 3 and object 5. Object 3 adds the circle and gives us this control panel to control the physics of the circle. And then the rectangle with an associated add physics script object, which gives us control over the physics settings of the ground. But what that means is, if you want to say change something about the ground, you got to think, do I want to change something about the rectangle? Like, do I want to change it to green grass, or move it up or down, or anything, make it wider? Then you want to do that with object 4, the rectangle. If what you want to change about the ground is something pertaining to its physics, you do that to the physics script object that's linked to the rectangle, which gives you control over all of the physics of the ground. So I don't want to overplay it that it's super confusing or anything, but it is something that sometimes you think, okay, I want to change the ball, and you got to think, well, wait a minute, am I changing the size of the ball, or changing its color, or what exactly am I doing with the ball? If it's something to do with how it's displayed, and if it's in a display group, and all that kind of stuff pertaining to the display object, the circle, then you select the circle. If it has to do with the physics of the circle, you select the add body statement for that display object. Questions? Any questions? So we'll take this a lot farther in the next days. We'll learn how to do all sorts of stuff with the physics engine. We'll start detecting collisions. We'll add sound effects. We'll start getting into damage. Like if the ball hits something that would take damage, then we'll impart damage to it. We'll change the appearance of stuff as it's damaged. We'll cover doing a health or a damage bar. And then on pretty much the last day, or maybe the day before the last day, the last material we cover will be explosions. So if you damage something to the point that it should explode, then we'll cover how to make something explode on screen, which is really fun. In the keynote, what I've left it on is this scientific activity. So as you're reading through this chapter 12, make sure to pause here and just go through some of this. So you can use this ball bouncing app that, if you're following along, we just coded in, but play around with the bounce and see if you can get settings that would make sense for a golf ball, or a soccer ball, a quaffle, a bowling ball, a meatball with no sauce, or a Play-Doh ball. So I'll be curious. I'll ask you kind of what your bounce values were for each of those. So see if you can figure out what would make stuff behave like that. The one caveat that I don't mention on the slide is, to make something really not bounce, you might also need to adjust the bounciness of the ground. Because if the ground is springy, even if you drop a cannonball on it, it'll still bounce up a little bit. So to get something to really die on the ground, you're going to have to go into the add body for the ground and change its bounce as well. Any questions at all? I hope this has been fun. I do want to get your feedback. There's a little quiz or Skype poll about the live keynote, if it's valuable to have me changing the keynote slides for you to watch, or you just as soon look at the PDF version of it, or have it printed out and look at that, or just what I just want to know where to spend time and effort. And then also, if you, I've tried, hopefully I've recorded the audio and the video of what we did today, and I'll post that. And then I'll be polling and asking, well, do you prefer this big hour-long video with everything, or the little ones that I've been doing with individual activities? So look for that poll as well. If there are no questions, I'm done. That was chapter 9 and a preview or at the beginning of chapter 12. We'll meet again on Tuesday at 10 a.m. I will hang around as long as you guys have questions and stuff. And obviously, if you come back later today and you have questions about the lab day, just let me know. I will be here.